Constant function y equals 2 is degree 0, because I could put behind it x to the 0. So it's degree 0. And the degree is the value of the exponent, the largest exponent in your polynomial. The leading coefficient is what value is in front of the exponent. It's 2. And the constant in this case is actually 2 as well, because the constant is the number without a variable. Okay? So linear is degree 1, because it's x to the 1. The leading coefficient is 3. And the constant is -4. The constant is the one that remains constant. And the only thing that's going to remain constant is something that doesn't have a variable on it. So the constant is -4. Quadratic would be degree what? Yeah, 2. The leading coefficient is the number in front of the largest exponent. So in this case, the leading coefficient would be 2. The constant is the number without a variable, so in this case it's +5. Cubic is degree 3, because the largest exponent is 3. If I don't have a number in front, what's my number in front? 1. So my leading coefficient is 1. And +3 is my constant. This one's degree 4. The leading coefficient is 1. And the constant is 6. All polynomial equations can be given in the expanded form as above. Some of them can be given in factored form. We're going to learn how to factor polynomials very soon. Determine whether each function is a polynomial function. Do this by checking if it can be written in the above form, and second, if the exponents and coefficients follow the given rules. So, is this one, and then if it is a polynomial function, give its degree. So this is x to the 5, x to the 1, and then nothing. So that's a polynomial, and it's degree 5. The second one is x squared, 2x squared, minus 4x to the -1. You can't have negative exponents. So it's not a polynomial. Y equals 7 minus 4x plus 1 over x to the 2, x squared. So x to the 2 on the bottom, you can move it up, but then it would be x to the -2. So it's not a polynomial for the exact same reason as the previous one. You can't have negative exponents, because this is actually a rational, not a polynomial. This one is 3x to the 4, 0.05x cubed minus root 6. Root 6 is just a decimal, right? It doesn't have a variable or anything, so that's a polynomial, and it's degree 4. Yeah. Root 6 is fine because it's a decimal. It's like 1 point something. If it was root 6x, then it wouldn't be a polynomial if there was a variable under the root, because then it would be to the half, and that's a fraction exponent. Whereas root 6 is just a decimal of some sort, so that's fine. Had there been a variable underneath this radical, though, say it was like this, root x, this isn't a polynomial, because the square root of x is x to the half. That's the same as saying x to the half. You learned that in grade 10, changing it to fraction exponents or rational exponent. So if this is x to the half, this is out. It's not a polynomial. So the previous one wouldn't have been a polynomial if it was like root 6x. If the root was over the 6 and an x, then it wouldn't be a polynomial. So this is not a poly, can't have fraction exponents. Because this would be x to the half. If you expand this one out, it's just x cubed minus something x squared, x in number. So if you have 3 factors like this, this is a polynomial degree 3. Because when you would expand it out, you'd get x squared times x, which is x cubed. And the last one isn't a polynomial because you can't have a variable exponent. That's an exponential, actually. So not a poly. Polynomial functions can be analyzed by identifying the degree and behavior domain and range and the number of x-intercepts that we're going to go into. So the chart below shows the characteristics of polynomial functions with positive leading coefficients up to degree 5. So all of these have positive leading coefficients. So degree 0 is a horizontal line always. Degree 1 is a linear function, right? Degree 2 is a quadratic, so it makes that U. Degree 3, you guys, is going to make this S shape. Okay? Degree 4 is going to make a W, or if it was negative, it would make like an M shape. And then degree 5 is just looks like this S, but with another bump in it. So it's 1 bump, 2 bumps, and then it finishes. Okay? Now they all have positive leading coefficients. They also all end positive on the right. Look, positive, positive. The constant doesn't follow it because it's just constant, it's just a horizontal line. When you have a positive leading coefficient, your graph ends positively on the right. It always gives you your end behavior on the right-hand side. So it says here, how would the graphs change if the leading coefficient was negative? What would happen if the leading coefficient was negative? They'd end what on the right? Instead of up, they'd end in the 4th quadrant. They'd end down. So what do you need to know? If you have positive leading coefficient, so an example would be y equals positive x cubed plus 3. You're going to end up on the right. So it ends up on the right. If you also notice, all of the odd degrees, the arrows are in opposite directions. So this one is up on the right, but it's down on the left. Degree 3 is another odd one. It's up on the right, it's down on the left. Degree 5 is odd. It's up on the right, down on the left. Okay, so odd functions, arrows are in opposite directions. Even functions, they're in the same direction. So look, degree 2 is a quadratic. You know that. If one arrow is up, the other one's up. Degree 4, if one arrow is up, the other one is up. Okay? So even functions arrows are in the same direction. Okay? If you notice every single one of these, the domain, all of the odd functions actually the domain of every single polynomial, unless it's restricted like a word problem, is XER. Look, XER, 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 because the arrow is either going this way, opposite-wise, or they're going this way, and they're still going in opposite directions, right, as the domain. But the range of odd functions is always YER. So look, degree 1, YER. Degree 3, YER. Degree 5, YER. But even functions, it's going to be greater than or equal to something or less than or equal to something because the arrows are going in the same direction. So they're going to have minimums or maximums, right? So this one here has a minimum. The lowest this graph goes to is -3. Isn't it 1, 2, 3? So this should be a 3. Y is greater than or equal to -3. And then this one goes all the way down to -7. So it's Y is greater than, well, it goes 6.91. That's what that one says. Okay. Now, if it was this way instead, so like a degree 4 was like this, it would be less than or equal to this maximum, right? Okay. Here's your key ideas. A polynomial function has the form f of x equals that. A graph that extends down in quadrant 3 and up in quadrant 1 is similar to the graph of y equals x, where the leading coefficient is positive, and it gives you like your little rundown of the different information. So we're going to go in here, we're going to do some questions on it. Let's look here. Now, if our equation, you guys, if our equation is in standard form, if it's in standard form like this where there's no brackets, okay, so standard form, so we'll go example, y equals 3x squared plus 6x plus 4. Okay. If it's in standard form, your leading coefficient tells how you end on the right. Positive and up, negative and down. The other great thing about it, if it's in standard form, is this back number here, the constant, is always your y-intercept. And the only reason why it's your y-intercept is because when you find a y-intercept, you fill 0 in for x, right? If I fill a 0 in for here, it's going to cancel, and a 0 into here, it's going to cancel, and I'm going to be left with y equals 4. So that's why when it's in standard form, so no brackets, your constant at the back is your y-intercept. Okay? If arrows are in opposite directions, it's an odd degree. If arrows are in the same direction, it's an even degree, right? Okay? So, this question asks us, for each polynomial function, identify the following characteristics: the type of function and whether it's even or odd. So linear, quadratic, cubic, so we could say degree 1, degree 2, degree 3, degree 4, degree 5. The end behavior of the graph, so how it ends on the right. The number, or how it ends from left to right, I guess. The number of possible x-intercepts, whether the graph is a max or a min, and the y-intercept. And then we're going to match them. Okay, so this one ends down on the right. So what does that mean it has? A negative leading coefficient. Okay, this one ends down on the right. So what does that mean? Negative. I should put it in brackets so it doesn't look like just a dash. No, that didn't make it any better. Negative leading coefficient. This one ends up on the right, so it has a positive leading coefficient. This one ends up on the right, so it has a positive leading coefficient. What degree is this graph? It has 1 bump, 2 bumps. Degree 5. If it only had like a sideways S, it's degree 3. If it has more than just a sideways S, it's an extra bump. Arrows in opposite directions, it's an odd function. So it's degree 5. And it's an odd function because we have arrows in opposite directions, right? Yeah. So if it has more than just a min and a max. Degree 3s can also have a point of inflection and not have a min and a max. So we'll deal with that in a second. This one has arrows in both. B has arrows in the same direction. So it's going to be an even degree. If it was degree 2, it would look like a parabola. Does it look like a parabola? It makes an M. If it makes an M, I would say it makes a math. You can write math behind it. It's negative. It's a negative leading coefficient and it's degree 4. So when it makes an M or a W, it's degree 4. So this one is a wonky looking what? Wonky looking W. So it's actually a degree 4 as well. And then this one has 1 max and 1 min, such that sideways S. So what is it? Degree 3. And remember, our constants, if it's in standard form, are our y-intercepts. So this one looks like we're going to have a y-intercept of 1. This one looks like a y-intercept of like 8, maybe. This one looks like a y-intercept of maybe -6. And this one looks like possibly a y-intercept of 2, right? So that'll help us as well. So now we're going to go and put in our, pick our equation. So this one has a negative leading coefficient because it ends negatively. So it's either C or B. It's degree 5, so it has to be C. You can also prove this is our y-intercept. Is it at 1? Yes. So this is C, equation C. This one's down. It's degree 4, so it's going to be negative leading coefficient. So it's going to be this one. We have to have a -6. Does it look like it's a -6 y-intercept? Yeah. So this is B. This one's degree 4 and positive, which is D, and it has a positive 16. Oh, this is a 20, not a 10, sorry. Positive 16, that looks like it could be. So that's D. And then this one, D has a y-intercept of 2, which is good, so that's A. Okay? Example 2. A skateboard manufacturer determines that its profit P in dollars can be modeled by the function P of X equals 1000X plus 1.25X to the 4 minus 3200, where X represents the number in hundreds of skateboards sold. So X is the number in hundreds of skateboards sold. So if I sold 500 skateboards, I would use 5. If I sold 1,000 skateboards, I'd use 10 because it's in hundreds. So basically, you just drop off 2 zeros, okay? So if it was 500 skateboards, I'd use 5. If it was 1,000 skateboards, I'd use 10. If it was 700 skateboards, I'd use 7, right? The reason why they do that is so that you don't have to make your window substantially huge to fill in the X values, right? Okay. So what is the degree of this function? What's the largest exponent? Yeah, 4. It's X to the 4, so it's degree 4. What are the leading coefficient and the constant of this function? So what's the leading coefficient? 1.25, because the leading coefficient is always the number in front of the largest exponent. I know that 1,000 seems like it's leading the equation, but the equation is not written in descending order. So it's actually always the leading coefficient is the value in front of the largest exponent. So in this case, the leading coefficient is 1.25. Dylan, what's the constant? The constant is the value without a variable. So the constant. Now, what the heck does that represent? Remember, the constant is when x equals 0, right? It's your y-intercept. The constant is just your y-intercept. So at y-intercept, when x equals 0, what does x represent again? In hundreds the number of skateboards sold. So what we're saying is when we sell no skateboards, when x equals 0, we actually have how much? Negative 3,200, which makes sense, right? It always costs more to make that initial amount. So for example, yearbooks. Yearbooks will, at first, will cost way more the less you buy, right? Because there's always, or books, when they make books, for the first time, that first book costs a substantial amount to make, right? Because you have to make all of the pages and everything to print it and everything like that. Then after that, they just press print and it prints it, right? But to get it all together, at first it costs a certain amount of money. So there's that always that initial value that it costs this flat rate no matter how much you sell, right? Now, that's why yearbooks, after you buy enough of them, it gets cheaper because it's X number amount to print each yearbook. And then you take that initial big cost and you spread it out over more yearbooks, it's going to be cheaper, right? So what does this negative 3,200 represent? It represents the profit when you sell no skateboards, right? It's how much in the hole they are before they even sell a skateboard, right? So it means they're negative $3,200 in the hole. Remember, it's your y-intercept, and your y-intercept is always when x equals nothing, right? X equals 0. Describe the end behavior of this graph. Is it ending up on the right or down on the right? Up. We're hoping it's going to end up. You guys, you're trying to make money, right? If it's ending down, after you sell, the more skateboards you sell, the less money you make, which would be weird, okay? So it ends up on the right, which makes sense because you have a positive leading coefficient. What are the restrictions on the domain of this function? Yeah. X has to be greater than or equal to 0 because why? Because you can't make negative skateboards. Now, some people will also say, but it also has to be less than a certain amount as well. Now, because it's a degree 4, remember degree 4 graphs? If it starts, it'll like start down and then it'll go up and then it can come back down. There could be a point at which it goes back down to 0 and then you wouldn't want to sell any more skateboards after that, which would make no sense in this case because you're going to keep profiting as you sell, right? But sometimes it'll be like, you'll have something like this, correct? So you're going to restrict from here to here because once you hit here again, you're going to go back down into the hole and you don't actually want to be in the hole, right? So you'd restrict your domain this way. But for us, we just want to right now restrict it to be greater than or equal to 0 because you can't have negative skateboards. Now, what I want you to do is plug it into your calculator so we can see this. So when I bring up my calculator, clear all these out. I'm going to put in my equation, which is 1,000x plus 1.25x to the 4 minus 3,200. And you have to put it in the way you say it. So if you say minus 3,200, you can't press negative 3,200. That it won't actually work out, okay? You need to put it in as minus 3,200. So Some people will go zoom 6. Zoom 6 is just your standard 10-10 window. And then they get angry because they're like, I see a line. That's fantastic. Remember, this thing has a y-intercept of negative 3,200, right? So my y minimum should be at least negative 3,200. So I'm going to make it be negative 3,500 because I want to see where it crosses the y-axis, right? Concurrently, I'm going to make this be positive 3,500 just to see what happens. This is a random guess at this point. It's my profit, so it's probably going to be higher than that. Well, I hope so, but who knows? And I'm going to make my y scale be 100. That's what each little tick goes up by. If you left your y scale be 1, it's not going to make it that you can't see it at all. You just won't see any ticks. Though you'll have like 3,500, well, you'd have 7,000 ticks on that little tiny space of your window. So it's just going to look like a solid black line, right? That's all that y scale does, is it sets your ticks so that you can actually see them. I'm going to make my x minimum be 0 because you can't have negative skateboards. And then I'm going to, right now, if I leave my x max be 10, then that means I'm actually looking at how many skateboards? 1,000, right? 10 is actually 1,000 because you add the extra 2 zeros because it's per 100. So I'm going to do 5,000 skateboards. I'm going to do 50. And then I'm going to make each of my ticks be 10. Like I said, if you leave your x scale be 1, it's not going to be a big deal. I'm going to make this be 100 just to see if I can see where my x-intercept comes back. Back to 100. Okay, and I'm going to make this be 10,000 just to see. Okay, so if I find my x-intercept here, it's second, so I can do this 2 ways, right? To find my x-intercept, I can make my second y equals be 0. I can go like this, make it thicker, press graph, and I can find out where those two intersect, and that'll give me my x-intercept. That's one way. So I can go second trace, 5, enter, 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 and it gives me 3.1 as my first intersection, right? Or you cannot do that. You can clear that out. And you can go second trace, number 2, and you have to be on the left bound of the x-intercept. So I'm at 34 and 7, a really large number. I want to be down here. I want to be negative, so I'm going to go left. Soon I should be able to see my tick. So now I'm below. So I'm on the left of the x-intercept, hit enter. Need to be on the right of the x-intercept, hit enter, and then enter. So 3.1 gets me the same answer either way. It's whatever way you like better. Okay? So what does that 3.1 represent? What does 3.1 represent? Right. So that 3.1, and I'm really rounding it. So how many skateboards is that? 310. Now, if I wanted to round it to actually break even, I'd have to go 311 or whatever it would be, right? This is the break-even point. So this is rounded at this point. So at 311 or 310 skateboards is when I would just make no money, right? After that, I'd profit. What's the profit from 1,200 skateboards? Well, you can take 1,200 and put it in for X. I put 1,200 in for X. How much would I put in for X? 12. So you could either go and put P of 12 and solve it. Go P of 12. And get your answer that way. Or your calculator will do it for you. It's the second way to try. You go, if you know an X value and you want a Y value, from your calculator. Once you have a graph, right, and you know an x value and you want a y value, what you do is you go second, trace, value. Value is where you can put x values in. And then you press 12 and hit enter. And, oops, I just exited that. And you get $34,720. Same as if you do the math, yeah. So example 3, on the axis given, sketch a polynomial function with the given characteristics. It has to be degree 3, so it's going to look like this, or like this, right? It's going to be an S shape. This would be positive leading coefficient. This would be negative leading coefficient, because it's how we end on the right. It says I have a positive leading coefficient, correct? So it's going to be this one, not that one. And it has two x-intercepts. How in the heck do we draw that with two x-intercepts? Well, let's think about it. Degree 3 functions can have at minimum one x-intercept, because they're going to have to cross through at some point. They have arrows going in opposite directions, right? How would I get one x-intercept? Well, if it's all, I'm doing positive leading coefficients just because it said. I want one x-intercept, I'd have to draw it through and then do my little S curve. So it's one x-intercept. If I want 3 x-intercepts, it's easy. Just draw the whole S through. So you would go, and remember I'm drawing all positives. So there's 3 x-intercepts. If I want 2 x-intercepts, what would I have to do? One of them is going to have to bounce on the x-axis. One of them is going to have a tangent point on the x-axis. Tangent point means you have, it just touches. So you have 2 x-intercepts, but just at that one spot. So you could go through it and then bounce here. Paying attention? You guys, you could get 2 x-intercepts this way. You could go through and then you could bounce here. And you have 2 x-intercepts. This is called the point of tangency when it touches in one spot and bounces. Or, and remember I'm only doing these for positive leading coefficients, you could have 2 x-intercepts where instead of going through here, you bounce first. Bounce. Pretend that just bounced and didn't go through. That doesn't look like it bounced. Bounces, goes through, and then comes back up through. And there you'd have your 2 x-intercepts. Yeah. Yes, this would have a multiplicity of 2. Whenever you have or 4, or 6, or 8, or 10. So whenever you have this little bounce happen here, it means you have at least 2 x-intercepts there. 2 x-intercepts that are the same. So this would be bounce and go down, so once, or I could have 4 there. It would bounce, 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 and come back down. So this would be multiplicity 2, 2, 4, 6, 8, keeps going, right? So what they'll say is what's the minimum multiplicity? Because if it's a minimum multiplicity, then they force you to 2. Yeah. Right. So if it was degree 3, then this would have to only have a multiplicity of 2. But if this wasn't forced to be a degree 3, this could technically be a degree 5 as well. It would just have to have 4 here and 1 here. Yes. Yeah. So this one here, it has a positive leading coefficient, so it ends up 2 x-intercepts. So I could draw either that one or this one. So you could have different versions. I'm going to draw it like this. Oops, pretend that touched. And goes through like this. There would be my 2 x-intercepts. Okay. You try B and C. Degree 4 is either going to make a W if it's positive leading coefficient, or an M if it's negative leading coefficient. The last name used to be Wagner. So I'd be like, positive, Wagner, math, negative, and that was how I remembered it. And now it's Lepp, and that doesn't, makes a 90-degree angle. Let's put it, make a triangle out of it, you know. So degree 4, negative leading coefficient, so it's going to be downwards, making an M, and has 4 x-intercepts, so it's going to have to cross through the whole time. So there you go. Yeah, that's my life, sadly. That right, yeah. Oh, Mrs. Lepp. That'd be negative, though. That's a bad decision. Mr. Lepp. I got nothing. Momentum. Medley. We're videoing this. I forgot. Awesome. It was a medley of math right there. Only we're going to get this, by the way. Okay, and then a polynomial with degree 4 leading coefficient 2 x-intercepts. So it's going to have to end up on the right. And if it has 2 x-intercepts, it's going to have to, oh, touch twice. Something like that. Pretend that's drawn nicely. It's not. It's not. Okay. For each graph of the polynomial function, determine whether the function has odd or even degree. Determine whether the leading coefficient is positive or negative. State the number of x-intercepts. State the domain and range. Okay. So we look on the right-hand side. Positive or negative? Negative. So it's from quadrant. Remember 1, 2, 3, 4. So we go counterclockwise. So it's 2 to 4. It's a negative leading coefficient. The function has blank degree. What degree is that? Degree 3, because it makes that little S shape. The leading coefficient is negative. And in this case, -1. Yeah. There are how many x-intercepts? 2. And what we can actually say is, if we wanted to, we could say x equals -3. And then we'd have x equals 1 multiplicity 2. You can have at maximum the same number of x-intercepts as degree. So this can't be a multiplicity 4 or 6 or 8 or whatever, because if it was a multiplicity 4, it'd be degree 5. It means there's 2 there. So that's what the tangent spot is. Yeah. X minus 1? Like if you were to factor it out, you had to factor you could do x minus 1, you mean? Yeah. Squaring it? Yeah, as a factor. Yeah. I get what you're saying. The domain, because it's degree 3 whenever it's an odd function, unless it's a word problem, which could be restricted, which we did up there previous, it would be XER. Because degree, or the domain of every polynomial is XER. The range of degree 3 and degree 5 is YER, because the arrows are going down and up, so they're including all of the Y values. Now remember, if we do interval notation, it's just negative infinity, positive infinity, round brackets, because it can't equal them. Okay? So B is quadrant 2 to 1. What degree is it? 4. Coefficient positive or negative? Why? Yeah. We look at our right-handed one. And because it's up on the right, it's a positive leading coefficient. How many x-intercepts? 2 x-intercepts. And if we listed those x-intercepts, they would both have no multiplicities because they go straight through. Okay, you only get multiplicities when they're bouncing of some sort. There's a straight line through, it's not. And the domain is XER. Oops, X such that there should be a line. Oops. And the range, we'd have to know our lowest Y. What's our lowest Y? Or greater. There's no graph down here, right? So my range is going to be y such that y is greater than or equal to -5, y-er. In interval notation, it would be -5 to positive infinity. And this would be negative infinity, positive infinity. Yeah.
So you don't need to have the same amount of X-intercepts.
No, you can maximum out, but there's no guarantee that you have to have 4. So if it's degree 4, you don't need to have 4, but you only can max out at 4. So you can never actually have more than that. But you don't have to have the total. So with degree 2 and degree 4, you guys, you don't even have to have any X-intercepts. If it's a degree 2, it could be completely above and have no X-intercepts, right? Or if it's a degree 4, it could be completely below and have no X-intercepts as well. But degree 3, degree 5, degree 1 have to have a minimum at least 1 X-intercept because the arrows are going in opposite directions. It's going to have to cross somewhere. Yeah. So you don't have a minimum. The minimum number of X-intercepts that a degree 2 has to have is none. The minimum number of X-intercepts that a odd degree 1, 3, 5 has to have 1. But maximum, you can only have as many as the degree. Yeah. C. What degree is this? Degree 5. It has a positive leading coefficient. It has 1, 2, 3, 4, 5. This crosses in different spots. 5 X-intercepts. Because it actually crossed, you can see it crossing through there. And also, you guys, you have to remember the constant is the y-intercept, right? So I can say the constant is this, and that's the y-intercept, or I can say the y-intercept is this, and you'd have to put in for the constant. They're interchangeable words in this unit, constant and y-intercept. But it has to be in standard form. Can't have any brackets in the equation. I guess we should have a double-headed arrow. Double-headed arrow. And this is in standard form. If there's a bracket in the equation, this goes right out the window. If there's a bracket in the equation, the constant isn't the y-intercept. And this would be XER, YER. Yeah. It could be when they have it in factored form. So like, if it was like this, let's say, in order to get the y-intercept, you could plug 0 in for each of these and solve, or you know that you're going to get the constant by multiply all the constants at the back. So you could go positive 3 times negative 2 is negative 6 times 2 is negative 12, and that would be your y-intercept. You'd have to expand it out. Mm-hmm. Absolutely. It just might not be in a nice form. It might be in factored form. And both of them have pros and cons. Standard form gives you your leading coefficient, so how it ends on the right, and it gives you your y-intercept, but it doesn't give you your x-intercepts. Whereas factor form gives you your x-intercepts. You can pull easily your y-intercepts, and you can pull easily your leading coefficient. Because the back 3 would get you your constant, and the front 3 would get you your leading coefficient. So your leading coefficient would be a positive x cubed. So it'd be very easy to pull the information that you could from a standard from a factored form. So interchangeable.